The evolution of the universe is being propelled by unknown energy. That energy is everywhere, from our planet's soil to the edge of the space. And we have got a good understanding of this through our space telescopes. Since their launch more than 25 years ago, space telescopes have been bringing the wonder, beauty, and secrets of the universe to Earth, creating images out of the light that has changed our understanding of the universe itself. Over 1.5 million observations have been made so far, and the number is growing. Telescopes are continuing to travel above the Earth's surface, free of the light distorting and blocking effects of our planet's surrounding, beaming back data that is revealing answers to some of our most pressing questions about the universe. While we are still at it, a study of stellar behaviors conducted over the past year has indicated that the newly launched James Webb Space Telescope will be able to reveal the birth of alien worlds and the age of planetary systems. So buckle your seatbelts because we are about to take off into the unknown. The Hubble Space Telescope was intended to be a general-purpose observatory, capable of exploring the universe in visible ultraviolet and infrared wavelengths, among others. To date, the telescope has investigated more than 40,000 celestial objects, providing scientists with some amazing views that were previously impossible to obtain from the ground. Along with the ability to completely block some wavelengths of light, the Earth's atmosphere is composed of moving pockets of air, which are responsible for the sparkling look of stars in the night sky. Images acquired by ground-based telescopes are distorted as a result of this motion. However, the James Webb Space Telescope is an example of a space telescope that is designed primarily for infrared astronomy research, 100 times more powerful than the conventional telescopes. In addition to being the most efficient telescope ever sent into space, its substantially increased infrared resolution and awareness will allow it to observe objects that are too old, far, or dim to be seen by the Hubble Space Telescope. These findings are likely to open up a wide range of questions spanning the domains of astronomy and cosmology, including observations of the first stars and galaxies, as well as thorough atmospheric characterization of exoplanets that may be habitable in the future. James Webb Telescope was launched from Kourou, French Guiana, on December 25, 2021, by an Ariane 5 rocket operated by the European Space Agency. It can also see objects in the immediate vicinity, including objects in the solar system that have an estimated angular rate of motion of 0.030 arcseconds, or less than that. This includes all known planets and satellites, as well as comets and asteroids outside of Earth's orbit, as well as Kuiper Belt objects. The observatory can also find opportunistic and unscheduled targets within 48 hours after making the decision to do so, such as supernovae and gamma-ray bursts, if the decision is made to do so. The James Webb Space Telescope is primarily concerned with 4 major objectives. Number 1, its primary purpose is to look for light emitted by the very first stars and galaxies that originated in the universe after the Big Bang. Number 2, investigate the origin and evolution of galaxies itself. Number 3, to comprehend the processes of star formation and planet development. Number 4, to research planetary systems and the beginnings of life on other planets. The research of James Webb Telescope will include questions such as, what was the appearance of the early universe? At what point in time did the first stars and galaxies appear? What was the evolution of the early galaxies like over time? What can we infer about dark matter and dark energy from our observations? What causes stars to develop and where do they occur? What influences the number of them that form, as well as the size of their individual masses? What causes stars to die and how their demise affects the surrounding medium? What factors influence the formation and evolution of planetary systems? These are all the important questions to consider. The James Webb Space Telescope will fundamentally alter modern astronomy in so many ways that it will eclipse even the Hubble Space Telescope in terms of the scope and depth of discoveries made, as well as the progress made in scientific research. However, one of the primary goals for Webb's first year of research missions is to seek for and investigate extraterrestrial worlds beyond our solar system, with a particular emphasis on how they came to be and whether or not they have the potential for water and organic life. There has been much speculation about whether or not aliens exist. Just as many believe they will visit us, as there are those that believe they never will and there is nothing to worry about. The truth is that nobody knows what the future brings and it's impossible to make predictions. In the past, there have been several close encounters with aliens. How close are we to making contact? It is envisaged that James Webb will write whole new chapters in the chronicle of our origins, the creation of stars, and the planets in the first year of science operations. James Webb will be the first spacecraft to orbit the Sun. It is Webb's study of star and planet formation that has enabled us to make the connection between observations of mature exoplanets and their birth conditions, as well as observations of our own solar system and its origins. The infrared capabilities of James Webb make it an excellent tool for showing how stars and planets develop for three main reasons. Infrared radiation is particularly effective for seeing through dust and picking up the thermal signatures of newborn stars and planets, as well as revealing the presence of essential chemical substances such as water and organic chemistry in the environment. It is possible for mid-infrared light to pass through clouds that are 20 times thicker than the clouds that visible light can pass through. This is especially important when it comes to watching young stars, which form quite quickly, sometimes in as little as 100,000 years, and are buried away within their natal clouds, as this is the case. When it comes to young stars, these clouds have not yet dissipated, therefore we are unable to perceive any visible light at all. Due to James Webb's infrared capabilities, we can now view and study the early beginnings of star formation, when gas and dust are still compressing inward to give birth to infant stars, which is critical for understanding the process of star formation. However, that is not the only thing we will discover within natal stellar clouds. The second reason has to do with the stars and big planets themselves, which are still in their formative stages. Both begin their lives as huge, puffy formations that gradually shrink in size as time passes, while newborn stars tend to become hotter as they age and huge planets tend to cool as they mature. Both release more light in the infrared spectrum than they do in the visible spectrum. In other words, James Webb is exceptionally good at finding new young stars and planets, and he can assist us in understanding the physics of their early evolution. Previous infrared observatories, such as the Spitzer Space Telescope, utilized similar approaches to detect star-forming clusters in their immediate vicinity. However, James Webb will identify new young stars throughout the cosmos, the Magellanic Clouds and beyond, with its advanced technology. Mid-infrared instrument, also known as MIRI, will look for warm molecular gas in the vicinity of numerous young stars, which could indicate the formation of rocky, potentially habitable planets. As a result of these studies, astronomers will be able to reach a definitive agreement on the concentration of bulk matter, including the origins of ice, at the earliest stages of planet formation. It should come as no surprise that a major amount of James Webb's early scientific inquiries are focused on determining how planetary systems construct the molecules that are thought to be critical in the formation of life as we now know it. We understand if you are unable to wait, but looking at the pace in which James Webb is making progress, we are going to witness some amazing, unimaginable things in the coming years. Thank you for watching, everybody, and if you enjoyed this video, please press the like button and subscribe to our channel, as it really motivates us in bringing you interesting and informative contents about our universe.